Next up on the Future Zone, we have two seasoned operations-savvy telecommunications and media technology executives. Ron Clifton, not content with his master's in electrical engineering and professional engineering registration, felt that broadcasting and media applications warranted cybersecurity expertise. So Ron Clifton became a certified information security systems professional. John McCoskey, as an IEEE senior member, SMPTE fellow, and prior two-term SMPTE governor, saw 2 Masters of Science degrees from Johns Hopkins and a BS.EE from Bucknell to be numerically overrun by his CTO ships at MPAA, PBS, Brief Original Broadcasts, and Discovery Communications, plus 25 issued US patents and an Emmy. Aiding and abetting their presentation is Mark Yonke, in case there are questions, difficult and technical. From their vantage, space itself is about to change, at least as regards what is needed by a broadcaster. Respectfully submitted for your perusal, Broadcast Channel Origination as a Service, from concept to operational implementation. Please welcome John McCoskey.
Thanks, Bill. I got to tell you, that is hard to follow. So, as Bill said, we've got a 3-person paper here. So Ron and I have kicked around this idea, I'm going to say, Ron, for 7 years or so, back before it was possible to do this. And the last couple of years, it looked like it was possible. And the one thing that Ron and I lacked was actually a station and the operations expertise and the people to do that. And so we partnered up with Mark, who South Carolina ETV is one of the biggest state networks in public television. I think you've got 10 full power TV stations, 9 radio stations, and is also a major distributor of content to other PBS stations. So he's got the capability to actually take the ideas that the 3 of us have worked on and put them to practice. So what we want to do is tell you about what we did to put those pieces together and actually put together a broadcast channel origination as a service. So our objective in this task was basically design and develop a cloud-based channel origination service for broadcast TV and network. We wanted to move everything we could into the cloud and take what traditionally had been for broadcast stations a build it every 5 years kind of infrastructure, and take all of that and move it into the cloud. Automation, play out, archive, the whole works. And on top of that, we were a little bit late kind of getting our ideas together on this before the PBS Technology Conference, which is always associated with the NAB show, in April. And so about 2 to 3 weeks before that conference was to take place, we decided we were going to try and start from scratch and do this and have it ready to show at that conference. So pretty compelling, task there for us. So today what I want to do is Ron and I will share with you kind of, one, why we got to the point of thinking this was the next step for broadcast origination and some of the data that's driving that, certainly for public television, but it applies to television overall, and some of the options that you can make in deciding how to put together channel origination as a service, because a lot of this stuff is commoditized and you have a lot of choices. And then we should have some time left for Q&A. So back in 2016, CPB, the Corporation for Public Broadcasting, saw that there was likely a cliff happening for stations that had been used to getting some federal funding and local funding for transitions of their infrastructure. Those funds were going away. They saw that stations were pushing out the kind of the end of life of their equipment. And they commissioned my company to go out and look at all of public media, so this was television and radio, and make an assessment of what the state of the infrastructure across public media was. So this is about 1,500 stations overall, 350 of those stations were television stations, and what we're focusing on here is television. What we found of those 350 television stations was a lot of interest in moving to the cloud. So public TV CTOs and chief engineers are pretty interested in doing new and different things and willing to take some risks. But we also saw that archive storage, master control, automation, playout were beyond end of life. A lot of stations had stuff that had been out there 7 years or more, really needed to be replaced, and that they didn't have the money to actually do physical capital replacement in the next couple of years. So there was an issue that, like CPB thought, the replacement needed to happen, but there really wasn't the funding to actually do a traditional capital refresh to build out their replacement systems. And they also saw, because of the size, if you think about this, PBS stations that collectively are the biggest station group by far in the country. So they represent about 25% of the full power stations. So there was a lot of collective bargaining power there in terms of cutting deals for services from cloud service providers. We also looked at the Devoncroft big broadcast survey numbers, and over the past several years kept seeing cloud computing and virtualization kind of rising up in the importance and interest for stations. And frankly, we saw organizations like Discovery take the leap and basically decide that they're going to move to the cloud and do cable-based origination in the cloud, which kind of took the risk away from a lot of other stations and network operators to say, okay, this can be done, and I'm not going to be the first person to go out there and take the arrows in my back. So that kind of teed up the landscape for us to be able to do this. The interest was there from the stations, and in public television's case, there was clearly a financial need to find a new way of doing things. And with that, I'm going to pass it to Ron, who will kind of walk through what we did.
Thanks, John. Am I on the mic? This one or the other one? You guys hear me okay? Okay, cool. So thanks a lot. Yeah, so as John mentioned, the work we've done here is in the context of the public television community, although seeing what Fox and Discovery and Sinclair and everybody else is doing, including PBS, what the work we've done applies equally to the commercial arena. So I'm going to talk a little bit about, first of all, the operational concept within the PTV context, and then we'll talk a little bit about the proof of concept, and then come back to some of the decision factors necessary to deploying a system like this. So this is a very much simplified block diagram of the public television broadcast system today. As John mentioned, 25% of the high power stations are PTV stations. PBS itself is not a commercial type broadcaster. They aggregate content from member stations and from other sources, put them up on satellite, AMC 21, KU band, and they provide it as a linear feed. In addition to that, they provide the file-based versions of that linear broadcast over satellite in what's called the non-NRT system. The NRT system is being replaced by that SIX. That stands for two things. It's the sixth iteration of the interconnection system, but also the S implies and notes that they are moving to a service-based model. From an historical point of view, it's important because as a vendor, I provided the fifth generation to John as the CTO at PBS, and then I had the honor and the privilege of working with Mark during the solution architecture phase as the proof of concept that preceded this deployment of the sixth. So the old version 5 is being dismantled this month, actually. So the importance of this color coding here is anything that exists is yellow. Anything that's red is also the national feeds. So a PTV station will get both file-based content, now through the 6 MPLS network, and also linear feeds off the satellite, at least for the foreseeable future. So what we're talking about, so here's the second element of the color coding. Anything in blue is what we're talking about, is adding a layer of cloud services for the public television stations themselves. It turns out that not all stations can go to the cloud. Then some of them are not allowed to go to an OpEx model. They have to stay with CapEx. Some of them are too small. Some of them don't have the need. But what we're talking about is moving some or all of a station's broadcast operations into the cloud. What we're showing you here are three basic elements. There is the cloud connectivity network itself. That's that little cloud between the station and the cloud services. You see a variety of cloud services at the bottom. lined up with the Corporation for Public Broadcasting survey results of what is needed, storage, media asset management, automation, playout, et cetera, master control, providing it through that layer. And we broke these up because of an importance of being able to understand the variables in each of these different elements when you're deploying a system like this or specifying it. The other bigger element of this is something we call the service hub, which is represented here by South Carolina ETV. Now, this system has got a lot of redundancy and disaster recovery built into it, and it's very subtle in this diagram. Ignore the big black, bold, two geodiverse double arrowheads connecting SCETV into the cloud, but there's a reason for that. And if you look at connecting the station itself, there's only a single thread there because there's backup systems that layer on top of that and allow for lower cost operating models. The black distribution lines showing backup and recovery and also showing new business models that will enable the PTV stations to reach out to those who are not part of this system. So the rubber hits the road on the details, and you want to look under the hood. You look under the hood of a car today, it's really complicated. So I'm going to take everything out, put it on the ground, and put it back in again. So there's our baseline public broadcasting system. It's operational. Is that we have to integrate with that without interfering with it in any way. So if you take a PTV station, we're going to take all of the equipment out of the RF transmission chain, put it in the cloud. We're going to keep all the things they do well, the studio, the production, their master control teams, their traffic systems, although when we did this initially, the traffic systems, most of them were on-prem. For those of you who know public broadcasting, the primary traffic management system is Myers ProTrack, and they've started moving that into the cloud as well. So these are the basic building blocks, the people and the content. Content's king. You add in the cloud services, and we're not showing MAM and the rest of it for simplicity here, but you see the nearline, playout storage, archival storage, the automation, and playout as building blocks. Don't worry about not connecting the stuff in the station at the moment. We're going to pull that all together here in a minute. So again, the color coding is important. Blue is the services, and the yellow is existing. So we have to connect this all together. You remember in the previous diagram, we had a single thread IP connection into the cloud from that PTV station. That station can opt for dual redundant and all the rest of it. Don't need it in this particular minimum system. So here you see 1 times 100 meg, and I'll explain 100 megabits in a few minutes. On the left, you see the 2 times 1 gig circuits. That's enough to handle at least half of the 172 public television stations out there because it's dual redundant, and it's really primarily there for backup. Now, excuse that cheesy graphics when the little keys dropped in. The importance of the architecture here is that with this kind of an architecture, single access from the station, IP, and then a dual redundant on the other side, you have control points for cybersecurity intrusion detection and intrusion protection. And so that's the significance of those. So the other part I mentioned we're missing there is the services hub that South Carolina has. It will be providing. Now, South Carolina today is one of the 20 authorized broadcasters on AMC 21 for occasional use linear feeds. So they already have the uplink and they're already authorized. So they're perfect for this, in addition to being the right size to be able to handle this as the first line of support for the stations. So they are connected already. They're part of the PTV system. So they're getting the national live feed for PBS 24/7, as well as access to all of the files that every station would want to have. So that's the significance of those red lines. So those are the building blocks. Let's see how we would make this work. So files that are generated and made at the station, local Kentucky 101, whatever it is, the special, those files are delivered over that 100 meg IP connection into the archival, nearline and archival storage. The schedules and playlists also come out of the traffic system and the master control into that same storage. Those same playlists for backup purposes and the files of a national feed basis are available through that geo-redundant dual connectivity in the lower left from SCTV as backup, and also to reduce the bandwidth requirements between the station and the cloud services. The control is completely browser-based, and we demonstrated that successfully. All the heavy lifting's in the cloud. You can take your iPads to the Starbucks when you have a disaster, snowstorm, whatever, and operate the station from wherever you have good IP connectivity. And the playout comes back, transport stream over IP, ready to go directly to air to what we call an IP IRD. And there's many manufacturers of these, Net Insight, Ericsson, a bunch of others make products that'll take IP in and give you SDI or ASI out and feed right into the RF channel. The significance of this, the bugs, the logos, the graphics, all the inserts, all of that stuff is happening in the cloud and being delivered ready for air when you come out to that IRD. How do we get live feeds? So PBS has got a mix of live and file-based. If you're only doing file-based like Discovery is, you're not so much worried about latency. You have lots of time to buffer these things and away you go. But PBS is famous for having frame-accurate switching between live and file-based. And we wanted to be able to maintain that capability here. So live feeds come back through that connectivity. In addition, the live linear national feeds are available for all the stations who have their little station here in the cloud through the South Carolina feed. Again, remember that's dual redundant and less susceptible to any backhaul fade problems at that end. The nice thing about this is that playout feed, because it's all IP, comes back to South Carolina. The reason that's important is if you do lose the primary feed into the station, they now have the ability to put it back over satellite for the backup. That's the extra redundancy. And on top of that, if you look to the left, that station, Kentucky, whatever it was, is having a special concert, and they make it available to the rest of the community who aren't even connected to the cloud. It can go back up on satellite, and that's the significance of the left-hand delivery part. So that's a little bit of a dive under the hood. We like it from an architectural perspective, very redundant and lots of fallback disaster recovery options. So as John was saying, we were pulling together this. We were invited to give a paper at TechCon based on the approach and work we had been doing. I wasn't sure who dared us first. Was you, John, or Mark? Said, well, geez, it's only the 1st of April. Let's get it up and running by NAB and TechCon. And so I was doing some work for Tata at the time and Grass Valley, who had just acquired SAM, Snell Advanced Media. And that's Mark on the left. Now, John and I were doing all the PowerPoint engineering, which is hard enough. You know, we've got to get the right fonts right and the right pictures and color coding. But he had all the late nights of getting the configurations up and running, integrated with his traffic management system, so he was running live on this proof of concept system. We were delivering SDI broadcast quality over the hotel's Wi-Fi, one HD, one SD, directly onto the floor, and no dropouts. It was about a second of latency because we were using bundled internet as opposed to the leased line. No dropouts, and it ran. We had an OTT version that people could look at on their phones while they're doing it. What you see there on the right is the browser-based master control system. And any of you who've played with some of these, you'll know they can be configured to suit your particular setup. We were running off tablets and off towers, up and running pretty quickly. So that was in April, May. And then in New Orleans at the end of May, we announced working with NETA, the National Educational Television Authority, to start offering this to the PTV community. And work is still ongoing in this and getting that ready commercially. So that was sort of what we wanted to do to prove to the PTV community this is available off the shelf. It can be made to operate smoothly. We were doing frame-accurate switching from live to live and live to file-based, back and forth, all driven by an operational traffic management system that was being used for day-to-day. And Mark was ready, I believe, to go to air if you didn't already go to air, just to prove you could do it. It was that reliable, and he was pleased with it. Now, part of our task, because we come out of the public community, was also in looking at that CPB study that John talked about a little earlier. I was the architect on the survey, so if any of you guys had to fill that out, I'm the guy you blame for some of the detailed questions. John was able to weed most of the tough ones out, but anyway. Coming out of that survey, in addition to all the technology and funding shortages issues, was a lack of skills within the community themselves. There are not a lot of cloud experts experienced in buying cloud-based services, and so there's an educational component of what our obligation was to the community and how to bring that out. So we put a little effort into trying to bring forward what you need to know if you're going to be buying services like this. keeping in mind that as a 25% of the nation's broadcast community, we have tremendous buying power if you leverage it and put it all together. So we're going to divide this. There were three pieces of this. There's the connectivity option, options that you have to look at. There's several options for connecting these stations. Public internet is getting more and more popular. It's got latency issues and jitter, but there's a place for it. There's direct internet access with all the major carriers, enterprise class public internet, managed public internet, people like VideoShip, LTN Global, and others who are offering a bundled service under a quasi-SLA. And of course, there's dedicated fiber available from multiple sources, Ethernet private line, MPLS. So these are sort of the basic options available. In the context of PTV, most of them are limited by their ATSC bandwidth output. We're talking 19.6 megabits per second with a little bit of overhead. We run these at 25 megabits per second for 1 HD and 3 SDs or 2 HDs. And how many are you running at CCTV?
1 HD, 3 SD.
Yeah, 1 HD, 3 SDs on that, on the 19.6, but you can do that on 25 megabits per second. Remember, these circuits are typically full duplex. So if you have 100 megabits, as we talked about, you have all 100 megabits available out to transfer files, pulling in 25 megabits per second, ready for air transport stream over IP. ATSC 3.0 will double that, but more importantly, you have the flexibility now of trying different what-if scenarios as the requirements and as the opportunities within ATSC 3.0 next gen evolve. So when you look at this from a station perspective, left to right, the big question marks on the left of the TV station is connecting into this connectivity layer to get to the cloud services on the right. Don't worry about the right. All those cloud service providers have on-net, high availability, low latency. They're there because they're serving thousands of customers, lots of connectivity. The problem has always been the challenge, cost, and otherwise is on that left. So that if you're looking at what you need to know to buy that kind of connectivity, there's a wide range of them. But bottom line, if you're going from public internet up to dedicated circuits, it's increased cost from that top down to the bottom. Jitter increases as you go back to public, decreases as you go to lease line, etc. Archimedes once said, if I give me a lever long enough and a fulcrum and a place to put it, I can move the whole world. You give me a buffer big enough and I can handle the jitter as long as you give me a customer who's willing to wait long enough on the latency. Anyway, so that's the basic element of that. The other element of buying power and looking for a solution, the biggest cost element is cloud storage. There's a number of vendors. Go back 3, 4, 5 years ago, Amazon was the leader. They're still the leader with their S3, but CloudStack open source, CloudStack Swift and part of the OpenStack community has come up in fast. Most of the big vendors all have different versions competing with Amazon. We divide them in between hot, warm, and cold applications. Nearline playout of being hot, warm is nearline, quasi, we want it next week, and then there's cold, deep storage. And there's a variety of pricing in there. There's a bunch of things to be aware of, like minimum storage commitments. Some of them, when you go into deep storage, you have to have a minimum commitment 180 days. Sometimes it's milliseconds all the way to days or hours to get stuff out. But there's varying in costs as well, and there's benefits along the cost axis. So that was it from a technical perspective on cloud storage. What you really need to understand in a broadcast community is what are we going to do for a service level agreement? Who are you going to call? And there's a bunch of factors. This is not Dropbox storage. This is object storage. You need it when you want it, and you need it reliably, and it's got to be there, and you can't lose your backup. So in addition to the monthly recurring costs that people are familiar with, and so much a gigabyte, there's also an ingress and egress cost. If you're just delivering to 3 or 4 stations, and away you go, and it's not a big deal, but you start delivering to hundreds of stations out of a storage community and you're paying egress and 50 channels a day, those bills go up pretty quickly. So some of the new players in the market are offering 0 or no egress costs, which is a game changer for this community. There are 2 major factors in identifying a storage solution. One is durability, which is, in this case, 11 nines is the standard in the industry. And that basically is a version of how many copies do I have out there. Do I have 2 copies spread across 2 availability zones, multiple copies in multiple availability zones in a single data center, across data centers, across geographic boundaries, East Coast, West Coast, US and Europe. Availability is probably, my data is there when I need it, and that's more of a factor of the connectivity you've got. Transfer rates around file acceleration, and of course, security provisions. When we do the 1 hour version of this, there's another section all around cloud service providers, but we're limited for time here. We boiled it down to one side. All of the major cloud service providers today are offering a suite of services to appease what we need in the broadcast, media, and entertainment space. You can see several people here talking recently about face recognition, machine learning, the transcoding functionality, all the building blocks we need, media asset management. They all are out there and they're offering them. The variabilities are between going public cloud, are you building on infrastructure as a service, where you can't necessarily control what's going on underneath the hood, all the way up to building on a private infrastructure as a service, where you have a very much more deterministic performance, less jitter, less determination, and SLA, service level agreement terms and conditions. Running out of time, but on the security side, if you can go to your service provider and demand an annual audit in accordance with ISO 27001, you can rest assured you've got a cyber secure solution, or at least you've made the steps to make sure you're close. National Institute of Standards and Technology have a framework, as does the Motion Picture Association of America and Marvel, all of them telling us what we should be doing. They need to be taken into account when you're picking a cloud service provider. So John, at the risk of jumping to conclusions, I'll hand back to you.
Thanks, Ron. I'll jump to the conclusions. How about that? So really our conclusions here, broadcasters overall, and the focus point we had was public broadcasters are facing these infrastructure replacements and driven by just aging equipment and the fact that the replacement cycle is shortening. So the key that we found was that there are operating expense options now that exist, and what you saw here was almost entirely operating expense and almost no capital expense for stations. Virtualization, cloud-based origination, the pioneers have made this something that is a model that you can deploy today and not be the one betting your job. So it's available and out there. As Ron talked about on the connectivity, storage, computing resources, all of these things have become commoditized. And in the example that we put together, there was no custom development at all. These were all off-the-shelf devices, off-the-shelf software, off-the-shelf services. Everything was available as commodities. And really finally, as we showed in this example of our 2-week effort, you can do this in a short period of time. So if you're doing it on an enterprise level, obviously you're not going to do it in 2 weeks. But this is not something that takes years of planning to implement. So that's it. I think we have 2 minutes left for questions.
Perfect.
Oh yes, I'm sorry. So obviously South Carolina ETV, we couldn't have done this without Mark and his team, but Tata Communications and Grass Valley really stepped up and helped us, and they were critical to making this this proof of concept go, because we couldn't have done it without any of those three. Any questions?
And Mark.
Yep, and Mark's here too.
And nice presentation, very clear. A quick question, maybe you covered it, I might have missed it, but with regard to reliability and quality of service, running a live system through virtualized servers where they won't guarantee anything with regard to delays and jitter, and more buffering solves everything, and time delay is evil, so you're working on both of those at the same time. How do you deal with that aspect? How do you prove it'll work, forever? And what happens when there is a failure? I know for Discovery, for example, they have another system running in parallel, and they just switch between whichever one is right. But I didn't see any of that here. So what do you recommend there?
Am I on?
Yeah, you're on.
So the equipment we used actually had built-in QoS, QoE built into it and looked after all the back channel necessary packet loss type stuff. But in this case, Tata has a tier 1 and SCTV was on. At their end, we didn't have any packet drop jitter type of issues. In the hotel, we did, and we had to open up the buffers a little bit. In an operational system, we would go something like a Telestream's QoS, QoE if we wanted to build it in, if it wasn't already built into one of the products. On top of that, you have continuous monitor control with something like a data miner from Skyline, we're looking at all the equipment out there and getting back statistics on what's dropping and not dropping. The choice, as you pointed out, with open internet, lots of jitter, second or so or more of a buffer. Well, in the cloud itself. Well, when you go in the private cloud situation, you've got in public cloud, then you have issues around jitter. You have issues of controlling the changeover of virtual machines ramping up and ramping down. In our particular case, we chose a private cloud solution going out to the public for some items that we were not necessarily mission critical or necessarily available for frame accurate switching. Without a public cloud, without the private cloud infrastructure we were using, that was built on a private infrastructure as a service, we were not able to get frame accurate switching live to live or live to cloud. That was a good point. I missed that. Thank you.
That was my question is, how, do you have a slide that details the frame accurate switching and more descriptive and how do you do that?
Remember, this is a lease line fiber, and typically it's like less than 25 milliseconds latency from there to here. That's normal in an MPLS network. We've tested that when I was at PBS. 15, 20, 25, 50 milliseconds latency for bringing content in here. Contrast that with 250 milliseconds off satellite we're all used to. When you're coming in from here, if this is an on-net MPLS network with that station, you should get, again, 15, 25, 50 milliseconds, depending where they are. If it is enterprise-class internet, and you're using something like a NetInsight Nimbra, you're going to get something like, what were you running, a second?
We had 50 milliseconds of delay.
50 milliseconds using
And that's no MPLS network at all. That was public internet at our station, public internet at the hotel.
Yep. So, did that answer your
And
question?
that's live switching between satellite, live switching between studio control to a file-based play out in the cloud.
Merrill Weiss Group. So you had ATSC 3 shown on there. Let me probe that a little bit. Have you given thought to where you would locate the transmission adapter, the broadcast gateway, in a situation like that? Would you put it in the cloud, or would you actually have it a physical broadcast gateway at the station site somewhere? I'll point out that there have been already demonstrations, demonstrations done with a broadcast gateway in North America and an exciter running in the Asian subcontinent successfully. So where does that lead you in terms of configuration?
We've actually thought about both. It's either at the station level or it's going to be at the cloud level. And most people are running their RF equipment through either a transmitter location or it's at their station site themselves. And we're playing with the concept of either or. And now with McCoskey being able to be brought into the cloud and everything else, and licensing is now just an upgrade in the cloud where we can be at ATSC 1.0 for a couple hours, and then we just pay our licensing fee for the next hours that we're going to do 3.0, and we want to do testing overnight or something like that. We're trying to figure out if it's going to be strictly in the cloud or if we're going to maybe have it a hybrid and actually have something run through our fiber to our transmitter site or something like that. So I don't have a specific answer at this point. We're still playing with it.
But keep in mind, too, that one of the advantages of next-gen ATSC 3.0 is integration with IP services. So if you've got everything inherently already in the cloud, that interactivity is there. And that link, although we think of it as a broadcast delivery into the station for rebroadcast, that's full duplex. That is an origin source coming back into that network. So that opens up all kinds of other potential.
Understood. So another possibility with ATSC 3, maybe a little more so than ATSC 1, is single frequency networks. Have you thought about whether there is any implication or any adjustment needed in the design of a system like this if you're feeding an SFN?
Wow.
We haven't thought about that.
And of course that
He was
depends.
talking about time syncing now across IP networks. There we go. Yeah, that's,
Of course, that depends on where you locate the broadcast
Yeah.
gateway, too.
yeah, that's a little aggressive.
Yeah, these are questions from somebody who's working on the ATSC3 STL.
Yeah, I can tell.
Thank you.
Hi,
Hey, Jim.
how you doing?
Yeah.
Jim DeFilippis, TMS Consulting. So very illustrative. A lot of thought went into it, obviously. But one thing that sort of is nagging at me a bit is the critical link is the link between the station and the cloud. And if that gets cut, if it's down, if you're dark, you have a backup plan where you come back around on satellite. But there are a lot of other things, activities are going on. There's traffic, there's automation, there's monitoring. How is that envisioned to be handled? Is that going to be shadowed by the hub? So when that happens, they take it over? Is it you establish an alternate connection? Do I get out my smartphone and?
Yep, that's
Yeah.
pretty much it. You bring out your iPad, you bring your smartphone, you go over where.
But what if the cell towers are down? That you're down.
Well, that's why, you know, the reason I thought about this, because being in South Carolina, we have tons of hurricanes, we have a lot of natural disasters that we have to deal with.
Floods.
And I can have my staff, if they need to get out of the state, but yet we need to keep our emergency communications running, they can
Right.
actually be in North Carolina or be in Chicago and actually running my station from anywhere in the world. And all the services would be running in the cloud, and it is geodiverse right now. And even the fiber, if it was just coming into our station directly, it's geodiverse coming in and out as well. But the beauty of it is, if I'm running either on my microwave or my fiber connectivity, let's say my microwave tower goes down, well, I've still got my fiber hopefully still up and it's not flooded out. So
Right.
we're trying to be as redundant as possible when we're thinking about these types of things.
Right.
How
But you're
redundant
not,
do you
you're
want
not
to be?
looking at the hub actually stepping in and taking it over then?
Possibly for other stations, yes. We have talked about that for other PTV networks where we could have all their services running. The beauty of the cloud, obviously, is that it's all already there and we can run it from anywhere we have to. Where do we get it to? That's the question. How do you get it there?
The critical factor in that, when you get that backhaul fade, like you just mentioned at the station, you've lost the ability to get the linear back to the station out to the RF. There's only one failure there, that's the fiber. Everything is still in that cloud, so the guys can pick up their iPads, go to their Starbucks, run the master control, make sure everything's still in there with the traffic system, all the rest of it. That whole feed, including the bugs, the logos, the graphics, everything is coming back to South Carolina, going out. Now, the work we did when I was at PBS.
Over satellite.
Sorry, good?
Over satellite is the
satellite.
backup.
Right.
So,
I got
but if
that.
the station wants more, they can buy another geodiverse at what, $3,000 a month or something, but they don't
Okay.
need it.
All right.
And it also can run off of our satellite truck that we have that's mobile.
Okay.
So if our uplink is down at Columbia, then we can have our mobile truck that can take it out anywhere else.
All right. Thank you.
Yeah, absolutely.
Greetings, I'm Harvey Arnold, Sinclair Broadcast Group. You guys have been doing a lot to expand and improve the PBS delivery system. And being a past PBS broadcaster myself, I commend this work. It's fantastic. What are you doing towards getting towards a totally lights-out operation in terms of systems monitoring and control?
We've been working with data miner.
Yeah, I mean, first there are a couple of options, and the whole concept of joint master controls in public TV, CPB incented stations to get together and form joint master controls. So there are a couple of big ones. I think the one in New York probably has 30, close to 30 stations
Now, yeah.
together. So for those stations, you know, they don't do master control. They don't generally do much in the way of traffic. They let that joint master control operation do that for them. You know, there are stations that collaborate and do that. A lot of stations that I know, you know, just they let it fly overnight. They don't run manned around the clock. They'll basically say nothing breaks anymore. So they'll just let it go.
So it is pretty much lights out for overnight, or?
Yeah.
Some stations are,
Yeah.
yeah.
Watch bandwidth utilization is very high on Thursday nights because everybody loads up their playout servers for a 4-day weekend. If they have an outage on a redundant system, they can fix it Monday and not going to ruin their fishing trip. So, It's adaptive.
Yeah, and the beauty of this collaborative cloud environment is that if a station, like again, if South Carolina is running this, and then one of the Florida stations doesn't want their staff to be working over the weekend, or they want them to be doing a football game over the weekend or something like that, well, now they call me up and say, hey, can you run my master control for 4 hours? We pull up, we have a login for them, and now we can run it for them.
Hi, I'm Jim O'Brien from Avico Automation Platform, and we've in several countries done quite similar architectures to this. And there's one additional element I thought I would mention, and that is the use of stream splicing as a very practical option. Full centralized control, remote control, those are well suited to client-server architectures like what we've got. So you don't have the challenges of virtualization. And do you see a place for stream splicing in this type of approach? It would seem a natural complement.
He said you're answering the technical.
Yeah. I mean, definitely. You know, when I'm using the splicing, and you're talking about for the ATSC stream splicing, is that correct?
For localized insertion, for
yeah.
local
So
control.
I'm actually using that because we're a state network, and I have 10 high-power stations. So if you think of us as a centralized master control that way, we're actually doing local inserts for either EAS or ads or anything else that we're doing locally. So we actually have a server on the edge at our transmitter location that is actually doing splicing for the network.
It's a natural additional backup element, and you know,
Yep.
we should talk about some
And
of the architecture.
you can do local storage there. You can do all kinds of different things. So if, again, you talk about how redundant do you want to be, how much high availability do you want, object of money, and you know, if there is no object of money, you can do anything you want.
You have a booth here, right?
I think the excellent irony is that the same moment you're telling me I could have a larger office, I can work from home.
That's right.
One more thank you for our speakers.
Thank you for watching. If you enjoyed this video, please tap the like button and also subscribe to our channel to receive notifications when we add new content. For more information about us, please visit SMPTE.org. We'll see you next time.